Okay, here's a big chart of solving systems of equations and other ways of stating the same problem. So it's basically just a quick review of a lot of the stuff that we've gone over when it comes to basic solving, like solving a system of m linear equations and n variables. And these Roman numerals 1, 2, and 3, and even Roman numeral 6 down at the bottom, which was talking about linear transformations that we'll do later. But for now, Roman numeral 1, 2, and 3 are the three ways of saying the same problem: solve a system of m linear equations, or solve a vector equation, or solve a matrix equation. And these are all the same problems here. For m equals 2 and n equals 3, a couple of equations: x1 plus 3x3 equals 4, and 2x1 plus x2 equals 1. And here's how you write it as a vector equation: x1 times 1, 2 plus x2 times 0, 1 plus x3 times 3, 0 equals 4, 1. And finally, here's how you write it as a matrix equation: 1, 0, 3, 2, 1, 0 times the vector x1, x2, x3 equals 4, 1. So all three of these give you the same augmented matrix: 1, 0, 3, 2, 1, 0 for the matrix A, and 4, 1 for the augmented portion. And after a quick row reduction, then transferring it back into equations, you get x1 equals 4 minus 3x3 after you move everything to the right, except for the variable x2, negative 7 plus 6x3, and x3 is a free variable. So then if you want a specific example, you can choose a value for x3. If you want a vector statement of the solution, then it's x3 times the negative 3, the 6, and the 1 for the free variable x3, and plus a constant for negative 7, 0. 4 and 5 are the same problem, but with a homogeneous vector equation, which means that I kept the same matrix, 1, 0, 3, 2, 1, 0, but now I just augment with zeros. So that's the same as the homogeneous matrix equation, AX equal to 0. And so you get back, notice this is probably the best thing about this handout, you get back the same portion of the equation of the solution, which is a span, x3 times negative 3, 6, 1. The only thing that's missing is the specific equation. So they're very closely related. The answer to the affine system of equations is the same as for the homogeneous system of equations, but with a constant vector added on as an extra specific solution. We'll talk about the linear transformation later.